So the second part of dividing polynomials is being able to divide polynomials using synthetic division. The word synthetic, of course, means fake, right? And so on the slide we have Bender, who's a robot, a synthetic person, being divided up. It's clever. Anyway, so before we do synthetic division, let's do another long division. Just because. It will make sense here shortly. Okay, so I'm going to use long division to divide x to the fourth minus 10x squared plus 2x plus 3. That's one that's going to go in the division house. So x to the fourth, I'm missing an x cubed term, so plus 0x cubed minus 10x squared plus 2x plus 3. And all of that is going to be divided by x minus 3. Okay, so I asked myself how many times does x go into x to the fourth? It goes in there x cubed times. I take that and I multiply it times both of those things in the divisor. X to the fourth minus 3x cubed, and then I subtract. Minus plus cancel. I get 3x cubed. Just bring down the next one is minus 10x squared. How many times does x go into 3x cubed? It goes in plus 3x squared times. Multiply the 3x squared to both of these terms in the divisor. I get 3x cubed and minus 9x squared. Subtract, minus, plus, cancel. Negative x squared. Bring down the next two terms, plus 2x plus 3. Okay, how many times does... Did I say bring down the next two terms? Oh well. Just bring down the next one, whatever. How many times does x go into negative x squared? It goes in there negative x times, and then multiply negative x squared, positive 3x, subtract, change the signs, cancel, negative x plus 3 when I bring down the 3. And then how many times does x go into negative x? It goes in there negative 1 times. Multiply, negative 1 times x is negative x. Negative 1 times 3 is a positive 3. And when I go to subtract these, changing the signs, I get a remainder of 0. So, a remainder of 0, what does that mean again? It means that x minus 3 divides evenly into x to the fourth minus 10x squared plus 2x plus 3. It also means it's a factor of x to the fourth minus 10x squared plus 2x plus 3. If you were to multiply this thing times the thing in the box, the quotient, you would get the thing that's underneath the division house. Okay. Alright. Yeah, we got that. So you might be asking yourself, well, why did I just do that if I was supposed to be talking about synthetic division? Well, you'll see. Trust me. Okay. Now, when your divisor is of the form x plus or minus k, where k is a constant, so this could be x plus 3, x minus 3, whatever, then you can perform the division quicker and easier using synthetic division. And it only uses the coefficients of the dividend, okay? So the previous one that I just did, I was dividing by x plus 3 or x minus 3, I don't remember. Anyway, so I could use this thing called fake division. I mean synthetic division. Like, for example, let me go back for just a second. Right here. I'm dividing by x minus 3. So this means that this whole problem could have been done faster and easier using this synthetic division. So we want to know how to do that because, hey, we love shortcuts. So let's find the shortcut for this one. But I'm going to tell you it's a little weird. Okay, so first of all, I only use the coefficients. I get rid of all the variables and stuff. Okay, so the demonstration here involves a cubic polynomial being divided by x minus k. Okay, but the pattern would be the same if it is a quartic or a quintic or whatever it might be. Okay, so again, I just use the numbers. So the first thing that I'm going to do is whatever I'm dividing by this x minus k, I'm going to change the sign of the k, and that's going to go on the outside. Do you remember that whole thing about the x, your x as being a liar? Well, if this is x minus 3, the number 3 minus 3 is actually going to be a positive 3, and that's what's going to go outside of the house. Okay, the a, the b, the c, and the d, those are the coefficients of our dividend, okay? I just don't put the variables in. So now watch how this proceeds. First thing I'm going to do is I'm going to bring that a straight down, okay? So that a is going to go there. Now I'm going to take that k that's on the outside of the house, I'm going to multiply it times the a, get ka, and I'm going to put it right underneath the b, okay? Goes right there. And now I'm going to add that to b. That's kind of strange because before when we were doing division, we subtracted it. Here, we're going to add these columns together. So this would be b plus ka. I'm not going to put that in that little circle, but that's what it would be. Okay, and you just keep proceeding in this exact manner over and over until you're all done. Whatever I get right here, it's just going to be a number. I'm going to multiply it times k and put it underneath the c. Then I'm going to add it to the c, and that's going to go right underneath it. That number, whatever it is, I'm going to multiply it times the k, and it's going to go underneath the d. I'm going to add it to the d, and that's going to be the very last number here. Okay? The first three in there, you will see those are going to be the coefficients. Here, let me get it up here. Those are the coefficients of the quotient in decreasing order. Notice the little arrows I put on there. Anytime I have a down arrow, that means I'm going to add up the terms. I'm going to add up the columns. Anytime there is a diagonal one, you're multiplying by the k, the number that's on the outside of the house there. Okay. The last number there, we said the first three were the quotient, the coefficients of the quotient. That last number there that's the remainder. Okay. Usually, whenever I do this, I put a little box around this last number just to distinguish it from the coefficients, and so that I know it's the remainder. So whatever this is going to be the ax squared term, and this, whatever this number is going to be the x term. This one's going to be the constant. Whatever is in that last number, that's going to be the remainder. Okay? Okay. So in this one, we are always adding the columns, but in long division, we are always subtracting. So that's a key difference. Okay? Now, the other thing that you have to remember, make some sort of note of, k can be positive or negative whenever I'm dividing by x minus k. If it's x plus 2, remember the x's lie to you. So I'm not going to put a plus 2 on the outside of the house. I'm going to put a negative 2 on the outside of the house. Okay? That's going to be the biggest mistake that some people are going to make. Okay. And then, of course, just like I've done before, I'm going to put a 0 as a placeholder for anything that I might be missing, any of the terms that I might be missing. So let's try. Look, it's that same problem that we started this objective with, but we're going to do this one by long division. No, I mean synthetic division. Okay, so this is x minus 3. So I can do synthetic division on it, but I don't put a negative 3 here. X is lied to, I'm going to put a positive 3. Draw my little box. Okay, now I'm going to put the coefficients of my dividend in here, but I'm missing a 0x cubed term, so I got to make sure I put a 0 there. So I got a 1, a 0, negative 10, a 2, and a 3. Okay. First thing I do is I bring down my 1. 1. I take that 1 and I multiply it times the 3 and I put it underneath the 0. So that's 3. I'm going to add the 3 and the 0 together. I get a 3. I'm going to take the 3. I'm going to multiply it times the 3 that's on the outside. I get a 9. Add up negative 10 and 9. I get negative 1. Multiply the negative 1 times the 3, and I get negative 3. Add up the 2 and the negative 3, I get negative 1 again. Multiply the negative 3 times the 2, or negative 1 times the 3, and I get negative 3. So I add those two together, and I get a 0. I put a box around that because that's the remainder, remember? And I have a remainder of 0, which means that x minus 3 divides evenly into x squared minus 10x, x to the 4th minus 10x squared plus 2x plus 3. Bah. Now, how do I write this answer? I divided x to the 4th by x. The power here is 1. 4 minus 1 is 3. This is 1 times x cubed. Now I just keep decreasing the order here. Plus 3x squared minus 1x minus 1. And there's the answer. All done. That was pretty fantastic, wasn't it? It's a little strange, but it works. Let's try another one. Let's divide this thing by x plus 3 using synthetic division. Okay, so this time, since it's x plus 3, my x's lie to you, it's going to be a negative 3 that's going to go outside the box. A negative 3 outside the box. Okay, am I missing any terms? I got a cubed, a squared, a 1, and then I'm not missing anything. So write down a 2, a 9, a 4, and a 5. Okay, first thing I do is I bring the 2 straight down. It's a 2. Okay, and I'm going to multiply the 2 times the negative 3, I get negative 6. Add these things up and I get a positive 3. Take the 3 multiplied times the negative 3, negative 9. Add them up, negative 5, multiply negative 5 times the negative 3, I get positive 15. Add them up, I get 20. Put a box around that because that's the remainder. My answer is, well, look at this. I got x cubed, and I'm dividing it by x. X cubed divided by x is x squared. 2x squared, just keep decreasing, plus 3x minus 5, and then my remainder is plus 20 over, what was it that I was dividing by? X plus 3. Ta-da! It's pretty fun. Here are 2 of them for you to try, okay? Right? You gotta, oh, long division, are you kidding me? Well, you can do it by long division if you want to, or why don't you try this new synthetic method. Pause the video and give those 2 a try. Okay, I bet you enjoyed that. Let's take a look at some answers here. Okay, on the first one, since you're dividing by x plus 3, x is lie to you, so it's a negative 3 that's going to go outside the house. You're not missing any terms, so you write down 1, 4, negative 1 as the coefficients. You bring the 1 straight down, multiply times negative 3, get negative 3. Add it to the 4, I get 1. 1 times negative 3, add it to the negative 1, I get negative 4. Multiply it times negative 3 again, and I get 12. Add it to the negative 1, 11. 11 is the remainder. Okay. So my answer here, I'm dividing a cubed by an x. That's going to be x squared, so x squared plus x minus 4 plus 11, the remainder over x plus 3. Okay, number 2, I'm dividing by x minus 1, change the sign, so it's a positive 1 that's going to go on the outside here. Not missing any terms, so 4, 1, negative 3, 7 are the coefficients. Bring the 4 straight down. 4 times 1, 4. Plus the 1, 5. Times the 1, 5. Minus the 3, 2. Times the 1, 2. Plus the 7, 9. And then, again, dividing a cube by an x, I get x squared. 4x squared plus 5x plus 2 plus the remainder, 9 over x minus 1. Whew. Okay, so a few more exercises and that will finish up this lesson.